Hello everybody. We're going to cover a couple different data structures today. In particular, some nested data structures, meaning structures within structures. We'll first start off with something called 2D arrays. This is like a primitive type. It's a little easier to set up, but then later on we're going to talk about some array lists. As we saw last week, there are some limitations within arrays. Array list, you can think of this as like a modern wrapper for arrays. All right, so there's gonna be quite a bit of overhead when we convert over from arrays to array lists. All right, but the point of today is just to visualize nesting. All right, so here let's first start off with two-dimensional arrays. I just want to help folks visualize what this can look like. Okay, in the future I'm planning on releasing a project that involves some sort of board game. It's probably going to be like tic-tac-toe or Connect 4. But as a to visualize how you can represent this, you can imagine it as a two-dimensional array. Right? It's not. You don't have to think of it as two-dimensional. You can think of it as nested, meaning you could create a array of size 4, and then for each of these elements, we could have them contain another array. All right, so yeah, you can think of it as two-dimensional. You can think of it as nesting. I'm probably going to use both of them. But yeah, here on the bottom, this is one way of declaring a two-dimensional integer array. All right, let me do this in the J shell real quick, just so folks can see what's happening here. So I'm just gonna load up my J shell here. Once again, arrays are fixed size. This is something that we covered last week. It was one of the biggest takeaways from here. So as long as you're comfortable with the differences between these two things, we got arrays on the left, and then we got array list on the right. Both of these pretty much do the same thing. As long as you're okay with the differences between them, this should make a little more sense here. So let me go ahead and declare this two-dimensional array real quick. So the way we do that, one way in Java, is by using these square brackets. This is saying we're going to do some nesting. So we have a two-dimensional array here, and then you can call it whatever you want. I'll call it a data here, actually, just to be super general. So yeah, and then I'm gonna give it some memory. So on the right side of the equal sign, this is allocating memory for it. In particular, I'm going to allocate memory for a 4x6, meaning that there's going to be 4 arrays, and in each of those arrays, there's going to be another array of size 6. Okay, so it's going to be 24 in total. Okay, so I just went ahead and declared a data structure, two-dimensional. Don't worry about this stuff right here. It might look a little harder to read. It's probably because of my line wrapping. Yeah, it is a little hard to read. Let me see what happens if I look at data real quick. Okay. I know this looks a little hard to read, but basically this is saying there is 4 arrays. Okay, so we got one array here, one array here, one here, and then one here. And in each of those arrays, there's 6 integers. Okay, they're currently initialized to 0. So if we were to access certain things, let me go ahead and access things. You might remember we can access using the subscript notation, these square brackets. So you could say like data 0, and then this gives us a single row. So if I said data 0, this is saying give us the first array in this nested data structure. So it's going to give us this over here. All right, so I'll press enter, and then yeah, we get this. I mean, all of these arrays are the same. They're all zeros. So the number 1 is the same, and then number 2, this is over here, and then finally the third one is the same too. But sometimes it's necessary to access that to go deeper into it. And if you want to go deeper, you can use these other notation here. This subscript again. If I said data 0, 0, this is saying grab the first array and grab the first element in that array. All right, that first element is an integer, so this returns a 0. All right, and so this is just accessing stuff. You could also write as well. Write means to kind of assign a value. So you could do something like say, hey, set the top left value to some number. So I'm just gonna set up to a random number like 35 or something. So this is a write operation. I'm assigning 35 to this element, and then now if I take a look at data, let me see. Let me type in data here. It is gonna be a little harder to read, but folks can see that our data structure now has 35 here. All right, and you can do that with other stuff too. Like if I said data at 3, and let me say like 1 here, just choosing some random numbers. So if I set this equal to like some random number again, like 20, right? Can folks kind of predict what's gonna happen here? All right, which value is gonna be changed? All right, well let's break through it. Let's break it down. So data 3, this says grab the element at position 3. So that element, so 0, 1, 2, and then 3. Okay, so the element is this whole array. All right, and then the next part is 1. Well, what is 1? That's over here, because we start counting from 0. So this expression should modify this value here. All right, let me go ahead and press enter. Okay, there it is. Press enter, and then let me take a look at the data now. And yeah, there we go. We see that it got changed here. All right, so this is just a quick intro on visualizing this data structure. There's multiple ways you can define a two-dimensional array. On the top, we did this before. That this is the style we did earlier, and it initializes all to 0 as a default value. Sometimes you might want to use a different style, like if you already know the values that are going into the array, you could use this style here. This style is useful for like hard coding data to initialize it to something. All right, so you could do this as well. We should probably apply this to a example. Let me load up my VS Code. Let's revisit a old example. There was this thing called a times table. So let me go ahead and load up your times table. Let me go ahead and run this real quick to refresh folks on what this is. It's been a few weeks since we've seen this. So let me go ahead and run this. Okay, times table. Let me run this. So you might remember this program, all it does is print out a times table, like over here. If you might remember from elementary school, you're probably asked to memorize this thing. So this thing right here, this multiplication table. Let me pull up a better picture here. Yeah, so a few weeks ago we wrote a program that pretty much prints this out over here. Okay. Let me see. I feel like I should make this a little nicer. Here, let me clean this up a bit because there's some. I just want to make it look a little neater. There's the column headers, which I don't really need, and there's the row headers. Let me just clean this up a bit. Let me get rid of that I over here. Okay. Let me see what this prints out. Just gonna clean this up. Okay, yeah, this looks a little better. If anything, let me put the tab somewhere else. I'll probably put the tab at the end. I'm actually gonna end up deleting this. I just want to make it look a little cleaner before deleting. Okay, cool. Yeah, so same thing. I just made it look a little nicer. Anyways, we should probably apply the two-dimensional data structure in a times table. Currently, this program is written to not really store data. All it's doing is iterating through 12 by 12 and printing out the product of each of those pairs. Sometimes it's necessary to store data, right? That's one of the applications for a two-dimensional array. So if we wanted to store this times table into a nested data structure, let's do that. Here, I'm going to erase all of this though. Okay, so once again, we're using arrays. I'm planning on using an array list later, just because this is a little more flexible. But let's do arrays first. These are fixed size data structures. So if we were to store this times table, we would probably have to represent like a 12 by 12 grid. All right, so let's go ahead and do that. Let me say, hey, I'm gonna make a 12 by 12 grid. Okay, and I'll call it like table here. I'll call it table, and then I'll also allocate some memory for it. So equals new int, and then 12 by 12. Cool. So this line is allocating memory for a 12 by 12 integer array. All right, let me make sure this compiles actually. Okay, Java times table. Okay, cool, it does compile. Sweet. So we should probably start filling this array up because it's currently all zeros, right? Like you could go ahead and print it out. Here, let me make a print. Let me do a sanity check. So this is like a print. I'm just gonna print all of the values in there just to see if we have like the right dimensions. It's gonna be more suitable to do like a nested loop, meaning that the outer loop is planning on going through all of the rows. So there's 12 rows in total, and for each of those rows, we should go through each column. So that's where the nesting comes into play. Right? For each of those, we're gonna look at the column. J is less than 12. Oh, wait, let me make it equal to, actually. I have an off by one error here. Less than or equal to, because I want to include. Wait, no, never mind. No, because this is because we start counting from 0. Okay, here, let me go ahead and this plus j here. Great. So this I and j is representing all of the possible positions in the array, meaning we can go ahead and print it out. Okay, I'm gonna do a printf here actually. Printf, and I'm just gonna do it tab space. Let's see. Put like a. So we're printing a number, an integer. So I'm gonna use %d here, and then I'm gonna tab space it. This way it looks a little nicer. And then what number are we putting in here? Well, it's the element that's inside of the ij position. So I'm gonna go ahead and access that ij position. All right, table ij. People see what this is saying. It's saying go to the ith row and then go to the jth column. That's what it's saying. All right, so this is gonna print it out all in tabs. I should probably put a new line here. The new line would belong here. The reason why the new line belongs here is because this inner loop prints out the whole row. Right, and once we're done printing the whole row, we should go to the next line in preparation for printing another row. All right, so let's go ahead and test this real quick. Okay, cool. Yeah, so we got all zeros, and the dimensions look good. It looks like a 12 by 12. Yeah, this looks good. Okay, so this is a sanity check just to make sure. If anything, our whole goal was to store data, in particular the products of every possible pair. All right. So one way we could do that is by another nested for loop. All right, another nested for loop that goes through all of the possible products. All right, so it's gonna just be like this one. All of the possible products. Well, we're 12 by 12. So let me do another here. Okay. Let me just rearrange my screens here. Whoops. Hold up. My other screen is glitching out. Okay. So let me do this inner loop here. This inner loop. So yeah, once again, this nested for loop represents all of the possible rows and column values. So then we can go ahead and get the product. Right, we could calculate the product, which is really just I times j. You've seen this in the previous example. So I times j gives us the product of the row and column, and now we can insert that product into the table. All right, so we could insert it by saying access the element and put the product into it. All right, but where are we putting it in? Right, so we're putting it in the I row and the j column. All right, so here, let me comment this here. So this for loop is constructing a 12 by 12 times table. All right. So let me go ahead and run this now. We should see a times table. Java times table. Oh, I reloaded my VS Code, so I got a CD again into examples. And let's go ahead and run this times table.java. Okay, great. Now we see the times table. Okay, cool. Hopefully people are cool with this. So we constructed a 12 by 12, and then we're just sanity checking it down here. All right. Okay. So that's the an introduction to two-dimensional arrays. We'll talk about some more applications later, but I just want to talk about array lists first. All right. So here, let me comment this out here. Put some more comments. I'm planning on replacing this main with a different method. Currently, this main is using arrays. And then later on, I'm going to make another main that does the same exact thing, but using array lists instead. All right. So a quick summary, once again. A array list is primitive. It's pretty simple. It's a little easier to visualize, but there's some caveats to it. There's some limitations. It's not really flexible. So sometimes you might need to use an array list if you have like a jagged table. But jagged means it's not like a rectangle or a square. Some rows could be different sizes. So if you wanted to have a little more flexibility, an array list would be a little more useful. All right, so we don't need to use an array list actually. I'm actually perfectly happy with this representation. It's very easy to read and very easy to implement. But we should talk about two-dimensional array lists. These are useful for jagged things. All right. So here, let me explain what jagged means real quick. Okay. So let's visualize what an array list can look like. Okay. So this is a flexible. This is very flexible, meaning we can declare an array list of array lists. All right, so here, let me take this step by step real quick. I know this is a little hard to read. So let me just take it apart. I'm gonna use a J shell here. Okay, so looking at the at only the left side right here, this is saying make an array list. All right, but if we want to nest things, like if you want an array list in an array list, we would say this is an array list of array lists. All right, but in Java, we need to specify what type of element it is. All right, so the inner element would be some sort of value here, some sort of a type. And in particular, I'm going to use the integer variable, the capital one. All right, if you're not sure what the capital integer means, this is stuff we covered like a couple of days ago. You might want to check out what the difference is between this. But basically, I'm using a reference variable. A reference variable is a little fancier, and it's got access to methods that the primitive one doesn't have. All right. So let me take this apart again. Cool. So this is saying make an array list of array lists, but the inner array list will contain integer elements. All right, and then we can name it whatever you want. So I'm gonna name it a table. And you know, you can actually stop right here. You can actually do a semicolon and press enter. But then if you did that, table wouldn't really be anything. So it might be necessary to allocate it some memory. All right, so here I'm gonna allocate it some memory and say, hey, I'm gonna set it equal to a new array list. Okay. So this right side is handling the outer dimension. We're gonna have to handle the inner dimension later. All right, so let me press enter here. Okay, cool. So I just created an empty table. One way you can visualize this is like this right here. We have kind of like a variable called table. Currently it has some memory, but there's nothing there yet. All right, so what I mean by null is there's nothing there, meaning the size is 0. So if you remember, array lists have a method called dot size. Table dot size. This is a method, and it's gonna give us a 0 here because it's empty. All right. Sometimes we'll need to add some things to it, add some more, you can call them rows. So let me go to the next slide. Here's a way of adding the inner dimension. All right, this is if you might remember, array lists have a method called add, which is putting an element in it. All right, in particular, the element, I'm doing another array list. This is the inner dimension here. All right, and let me go ahead and get this over here. So let me use a J shell. So let me just add this. This is just one way. So I'm saying table. I want to add a row. Okay, so I'm going to add a row, and each row is an array list of integers. So you could say give each row some new memory. Okay, and that memory location, that memory is going to represent an array list of integers. All right, and yeah, don't forget these parentheses here. These parentheses are important. Okay, so let me press enter here. Okay, so I successfully added a row, meaning the table is now size 1. And you can visualize that by saying table.size. And then, yeah, so we get size 1. We can go ahead and add another array. All right, so I'm just going to do this again. Let me go table.add. So I'm going to do this one again and then enter. And yeah, now we should see our table size is a little bigger here. Yeah, so our table size is 2 now. This means there are 2 array lists of integers. All right, but these array lists or rows, they are empty. Right, so you could visualize that by diving into the data structure. Okay, so a table right here, if you want to visualize it, you could. I am in a J shell, so the J shell is rendering it a little nicer. But table right now is represented as these square brackets here, which is pretty much representing this diagram. One way we can access individual elements inside of here is by using this method called get. So the get method. Let me go to primary docs real quick. This is ArrayLists Java. There's a method called get, which takes a number and then it returns the element here. Meaning, if I were to do like if I were to do like table dot get 0, this is saying, yeah, grab the first element as 0, and the first element is an empty array list. All right, so you could do get 0, enter, and yeah, we see an empty array list. It's a size 0 or null. You could also do get 1 here. All right, get 1. This is going to give us this second one, and it's also empty. All right, but be careful for going past the bounds. By the way, if we were to like do get 2 here, 2 doesn't exist because we have a size 2, so 0 to 1. So yeah, be careful with that. But anyways, we can go ahead and populate this inner dimension now. One way we could do that is by using this add method. So it's going to look a little hard to read because we got methods and another method, but we could break this apart. If our table currently is empty, and maybe we want to add some things into it. So if we wanted to add some things to this first array list, we would probably have to access it first. So I'm gonna access the first row, and then now I can add an element. All right, this first row is an array list. All right, it's an array list, meaning we can add to it, because array lists have a method called add here. So I'm using this method, which adds an element to the end of the list. All right, so let's go ahead and do that real quick. So I'm adding some element. I'm just gonna add 5 here, some random integer. And then if I press enter here, we get true. This means we successfully added things to it. All right, it's just a return value. We could go ahead and visualize a table now if you want. So I'll look at the table, and yeah, see, our first array has 5. Let's do this again. So table.get 0, grab the first row, and then I'm just gonna add 20. All right, add 20, and then successful. Let me go ahead and look at the table here now. And yeah, so we have the first array is 2, and then the next one is 0. Let me go ahead and add something to this next array list. So we can do that by saying 1. This is saying grab this, and then now we can go ahead and add some number here. I'm gonna add a 9, and then now our table is jagged. Do people know what I mean by jagged? It's like it's not really like a square. It's not really a rectangle. It's not symmetrical. So yeah, array lists are very flexible. You can have variable length structures inside of here. All right, so this is that's what I mean by jagged. All right, so this is just kind of a practice on navigating these things. It's also possible to overwrite some things here. There's a lot of things you can do with array lists. I'm just gonna do one more method here. Like maybe for some reason you wanted to replace a value, and the one way you can replace it is using a method. Let me take a look at the array list methods. There's some method here. I think it's called like set. Yeah. There's a method here called set, which is a replacement method. It takes a number, the position, So you'd specify the position and what you want to put there. So if you wanted to if you wanted to replace this number with some other number, well, first we'd have to access it. So let me go ahead and access it. So we would say something like, so access this array list. So that's table.get 0. This is accessing it. Let me just prove it. So yeah, this accesses it, and now we can use this set method here. We can go dot set. All right, it's because we're saying, hey, grab the array list and then set something. In particular, I'm gonna grab the position. The position here, I'm planning on replacing this number. So this number is represented by position 1, and then we can now add in another argument. This represents what we want to put into there. All right, so let me put in like a 69 for some reason, or just a random number. Okay, cool. So let me press enter and see what happens. Okay, don't worry about what this 20 is, but basically this method also returns what got removed. So we don't really care about this 20 for this scenario, but our table now looks like this here. You see what happened here? We use the set method to replace a number. All right. So yeah, that's just a quick intro on two-dimensional array lists. All right, you don't have to think of it as two-dimensional. It's you can think of it as nested as well. All right, because later on we can do like 3-dimensional, 4-dimensional, but for now we'll just stick with 2. Okay, so now that we're a little comfortable with navigating array lists, maybe we could apply this to our times table. All right, so our times table here is currently implemented to do an array. Once again, I'm perfectly happy with this implementation, but for the sake of learning, let's go ahead and do this using array lists. All right, so it's gonna look a little weird here. Let me comment this out. Comment all of this stuff out, and I'm gonna do another main here, which it's really gonna do the same exact thing. I'm gonna using array lists. Okay. So first things first, one way we could declare the table is like this right here. We could first say allocate some memory. All right, so let me go ahead and do that over here. Array lists, and this we are doing some nesting. So the array list, the outer dimension is going to contain more inside of it, and this inner one integers, just like earlier. All right, but this is the capital integer. It's a reference variable, and you can name this whatever you want. I'll name it table. And yeah, you can actually stop right here, but it won't have any allocated memory. So I'm going to allocate it memory for a new array list. All right, so let me just comment this out real quick. This is allocating memory for an array list of array lists of integers. So that's what this is saying right here. Array list of integers. Okay, cool. Let me compile this actually. It's really easy to have typos at this point, so let me just verify. Sweet, no typos. Okay, cool. So this is size 0. Maybe we could go ahead and start constructing the rows. So with the times table, we should have 12 rows. All right, and we saw earlier we can add rows by adding array lists to the outer dimension. All right. So let me go ahead and do that over here. But we're going to do this 12 times. You know what I mean? The 12 rows. So it might be necessary to do a loop. All right, a loop that does something 12 times. Okay, there it is. And now we could go ahead and loop this. We can say add a new table. Add a new array list inside of it. So I'm going to go ahead and say table.add a new array list of integers. Okay, don't forget these parentheses. Cool, cool. So this, let me just comment this. Allocates memory for a row. That's what it's doing, and we're doing it 12 times. Okay, let me do a sanity check here real quick. I just want to make sure that it's constructed correctly. It's not constructed correctly yet because we didn't handle the inner dimension. But I just want to check the size. So let me print out the size here, or the number of rows. Number of rows is. Let's see. Let me use a print f actually. Print some digit and a new line here. And there is a method called dot size, I believe. Array lists have a dot size method, so we could be a little more general. Dot size here. Let's go table dot size. This is saying how many rows are there. All right, it's not really doing the columns yet. Okay, let me see. Okay, number of rows is 12. Okay, cool. Cool. So all we did was this over here. We added 12 empty array lists. Right. Now we should populate the columns. All right, let me do a comment here. Populate the columns. Okay. And there are 12 columns for each row. So we should have another loop here that goes through each column. All right, so let me do that here. There's 12 columns. All right, and then now we can go ahead and, I guess, calculate the product. It's kind of like down here. Down here in our old method, we calculated the product, and then we inserted it to the table. All right, so let's calculate the product first. Let's see. Let me go like let me calculate the product. Well, the product is equal to I times j, because that's all the possible pairs. And then now we can go ahead and insert to the inner dimension. All right, and we saw how to insert. Well, first you'd have to access the row. All right, so this table.get number, this is accessing a row, and that row represents an array list. So then we can add to that array list. All right, so that's how we can insert here. We can do a table.get and then I, because we're working with the ith row. So we can go ahead and insert or add. All right, we can go ahead and put in the product here. All right, there we go. Let me test this real quick. I should probably update this sanity check to go through the whole, to print out all of the elements. So let me do a quick sanity check here. I'm gonna write another loop just to go through all the rows and columns. Okay, sanity check. Print. Okay. I is less than. You could put 12 here, but by this point, right, when the program gets here, we can generalize this 12. We could generalize it as a table.size, which is pretty much 12, and then plus I here. And, cool. So let me go ahead and yeah, this is going through all the rows. Now we need to go through all the columns. J is less than. This is going to look a little trickier, but how do we get the length of each column? Well, we would have to access the inner array. So the inner array you can access by saying get I. All right, this is saying grab the array at the ith position, and then we can get the size of that array. All right, so this is representing the column size. Okay, I know it looks a little tricky, but hopefully people can see that. And then let me go plus j here. Cool. So now we can go ahead and just print it out. Let me go system.out.print. Print a number here, and then let me tab space it. So the number is going to be what we access at the table. So we gotta dive into the dimensions. We gotta say, hey, go to the row, right? The row is I, but then we also have to go deeper and get the jth element there. J represents a column. Okay, so this inner loop prints the row, meaning once we're done printing it, you could do a new line. We're printing a blank new line to get ready for the next row. Okay, let me test this again. So Java times table, and yeah, it looks good right here. Cool. So yeah, we just did the times table again in an array list. All right, people cool with this? Let me check on the chat. Okay, sweet. Okay, yeah, so that's it for the array lists. We covered 2 different ways of doing the same exact thing. Array lists are a little trickier to work with, but it's very powerful. it's way more powerful than an array. Okay. Cool. So let's summarize these things real quick, and then I'm planning on going on to a different topic. Okay. So all we did was do a times table. There are other applications that nested arrays and array lists can also work with. Like for example, we could store relational data. If you're working with like Google Sheets, Google Sheets might download into some sort of tabular data. Here's what I mean. Let me check out this website actually. So there's this website that has coding competitions. It's got large data and some algorithms. I've competed in some of these competitions before, but taking a look at some of these data sets, we'll see that it's organized in ways that you might need a nested data structure for. So let me take a look at some data sets here. Let me see. Oh, they got data sets on movie trailer comments. Let me take a look at this real quick. Okay, I think this is a good one. Okay, I can see it says CSV here. CSV stands for comma separated values, meaning it's probably some sort of nesting here. So let me take a look at this. So this is a data set. Let's see. Okay, let me download this real quick. Okay, it's 15 megabytes. Let me download this. Oh, okay. Hold up. I need to log in. Let me log in on my other screen. Log in. And then okay. Okay, let me go ahead and download this. Download. I'm just gonna take a look at this here. Cool. So I'm just downloading a file that contains data. It looks like it's got YouTube comments in there. Let me up. Where's my? Let me open it. I'm gonna open it in Notepad just to be very plain. Okay, it is a pretty large file. Well, 15 isn't that large, but okay, cool. So here's a bunch of data here. It is a little hard to read, but all you really got to know is this is tabular data. There's a bunch of rows. Each of these rows have some columns here. Like the columns represent some sort of video ID, the title of it, the comment, and then some other data here. So you can think of this as a nested data structure. There's rows, and each of those rows have columns that has data. All right, and this is for like machine learning stuff. But to simplify things a bit, if you're working with Google Sheets or Microsoft Excel, you could write Java programs that take in that data and maybe do things a little better than Excel can. All right, so that's just the one application. You can do a lot of data analysis. Okay, you can also do graph theory. This is very related to the relational data. Graph theory, you can think of this as like representing a network, or maybe like a map. Say you're on like Apple Maps or Google Maps. You can think of these as cities where the distances are represented by the arrows. So imagine this as city 1, city 2, 3, and 4, and then these arrows are representing roads. They are one direction. So sometimes you can have two directions, like over here, between city 3 and 4. There's two different directions. But this is also weighted too, meaning these numbers represent the cost of going there. So it's saying from going to city 2 to city 1, it costs 3. You can think of it as like traffic, like or time, or distance. It's the higher the number, the more expensive it is to travel from some place to some place. All right, like going from city 1 to city 6. I mean, city 1 to city 3. All right, what is the optimal path? Is it going straight to 3? No, because the cost is 6. A better one is to go to 4 and then 3. All right, because the cost of going from here is going to be 4. All right, 3 plus 1. All right, so you could represent this a graph as something called an adjacency matrix. Adjacency matrix is the fancy word of table. All right, and this table here represents the cost of going from some city to some city. Like from well, first of all, see this diagonal. Everything in this diagonal is 0. The reason why it's 0 is because it costs nothing to stay at that certain place. Right? Like if you go from 1 to 1, it doesn't cost anything. But if you go from 1 to 3, it's gonna cost 6. Right? And that's represented over here. Right? This is representing going from 1 to 3 costs 6. But if you go 1 to 4, this costs 3, which is over here. All right, so yeah, you could represent adjacency matrices, which can help out with a lot of certain problems. If you're interested in these types of problems, this is called a graph theory. It's good for optimizing networks. And in one case, you can think of it as like Google Maps. Here, let me pull up Google Maps over here. Deep inside Google Maps uses some sort of graph theory here. Like let's say Santa Cruz, UCSC. I mean, let's see how long is it gonna take to travel to UCSC from Cabrillo? All right, so I'm just gonna go Cabrillo to UCSC. It's gonna cost 17 minutes, and it looks like the most optimal route right now is going here. So start Cabrillo, go down here, go to Highway 1, and then all the way to UCSC. Right, so this is one route, but there's other routes too that cost a little more. Like this route probably costs more. Let me see. Okay, I forgot how to read this on Google Maps, but yeah, there's tons of different. Whoops, I accidentally dragged something. Okay, whoops, I messed it up. Let me redo this. Let me refresh this actually. Refresh. I need to do this again actually, because the URL is messed up now. UCSC. Let's go from Cabrillo. Cool, you see all these routes here. Wait, what's up with this route? What? That's a weird route. Oh, this is taking the bus. Let me go driving. Okay, cool. That makes sense. I guess if you're taking the bus, you're constrained, and you might be forced to go like somewhere else that's far away. But yeah, the graph theory, it kind of goes through a bunch of data and checks the costs of going there. So there's a couple different routes. Yeah. People see what I mean. There's adjacency matrix. You can use like a nested data structure for this. All right, to tons of uses. You can also, not just for mapping, but you can use it for like networks, like on the internet. Like what's the fastest way to get from this server to another server? Right, so it doesn't have to be this stuff. It could be game theory too, like navigating mazes and programming bots to go through a certain route. So yeah, it's pretty cool stuff. We're not gonna cover too much on graph theory in this class, but if you're pursuing computer science a bit more, you'll probably find this pretty interesting. All right, so yeah, what's some other use cases for nested arrays? I'm planning on releasing a assignment next week that works with some kind of board game. I haven't made it yet. It's probably going to be tic-tac-toe or Connect 4. Something that everyone has probably played before. So you can represent these board games as nested data structures. For here, the tic-tac-toe, this is a 3x3 grid. You can use an array or an array list. And then the inner element would be like maybe a number, right? Like player 1 is here, player 2 is here, right? Or you could use like strings, right? For if you want to use like emojis or something. But yeah, Connect 4 is also very similar. You have a nested data structure, right? You got rows and then columns inside of the rows, and sometimes you'll have to iterate through them, like calculate the winner. Right, like part of but both of these games will require to calculate a winner. Like how do you look at a data structure and tell who won so far? Right, so I'm planning on releasing something with this. All right, so yeah, that's a quick intro on 2D arrays and 2D array lists. I recommend doing a bit more reading on this. I'm not sure if the primary source has this stuff. Let me see real quick. I don't think the primary resource covers nested arrays that much. Let me see. Let me click through here. Yeah, it doesn't. I'm not sure if they cover it, but you could Google up some stuff on this. I think W3 Schools has something good. Let me look some stuff up. Let me look up nested arrays and array lists in Java. There's tons of resources. Just finding the right ones is a little challenging. Just because a lot of the internet is kind of AI generated now. Like this right here. Let me see if this was generated. I can't tell. I think this might be written by a real human. Is it? It could be. Yeah. You could look at this stuff here. I would probably recommend maybe W3 Schools. This is maybe a little more credible. I'm not sure if they covered nesting here, but let's see. So this is an array list. Let me look down here. Did they do any nesting? I'm sure they do it somewhere. I just gotta click around. Okay, it looks like W3 Schools does have some exercises on multi-dimensional arrays. These aren't array lists, but if it would be a good practice to read through this and maybe convert it to an array list, just for a practice. In my opinion, array lists are way better. They're super flexible. Although their syntax is a little harder to get used to, they're way more powerful. And if you were to use arrays, you're kind of handicapping yourself. So yeah, you could take a look through here. This is arrays. I would also look at array lists too. So maybe Google up something like nested array lists in Java. And then there's probably going to be something here. Let's see. Oh, it looks like I clicked on this one before. This one's pretty good. Oh, they do some graph theory here. Nice. So graph theory, we just talked about that. Pretty cool stuff. 3-dimensional. Interesting. Yeah, cool stuff. Yeah, highly recommend taking a look at further readings for this as lab time. All right, and yeah, if you could let me know what you in the lab report, if you could let me know how you practiced it, that would be great. Just because we're going to release some sort of 2-dimensional board game later. Okay, so that's it for this topic. We spent like 2 weeks talking about arrays, array lists. We spent a lot of time on algorithms too. And let's see, what time are we at? Okay, we got 1 more hour left. I'm gonna make another video in just a bit, just to be a little more separate. But yeah, that's it for this over here. The next video, it's going to be covering something called file streams. I'll publish it sometime tomorrow. I gotta set some stuff up for it. But yeah, we're here on week 11. All right, we finished talking about algorithms, nested data structures. I'm gonna release an assignment very soon, and I'm also gonna release another short video on this, file input, output, and exceptions. If you want to take a quick sneak peek on this, like it's usually a good idea to do readings before the lecture. And if you want to do some readings on this, I would recommend the primary source, the recommended resource. There's a section on file input and output. I think it's over here in section 4. Yeah, in part 4, there's a section, files and reading data. I highly recommend going through this, at least reading it. You don't really have to play around with the code too much yet, unless you want to. But yeah, in the next video, I'm gonna cover this stuff. Like, what are files? Well, files is data that lives in our storage, like a hard drive or your solid state drive. So yeah, it should be some pretty cool stuff. Okay, yeah, that's it for today, folks. I will see you all soon. Thanks for being here.